Today we'll be looking at laws of exponents. Let us start. The first law. Suppose we have two terms multiplying each other. We have two terms which have the same base, a multiplied by a. Actually, it's a to the power p multiplied by a to the power q. We simply take one base and then we add the exponents. We only add provided the sign between the two terms is dot product or multiplication sign. For example, x to the power 4 multiplied by x to the power 3. The answer will be x raised to the power 4 plus 3, which is x to the power 7. Another example, y to the power 5 multiplied by y to the power negative 8. Our answer will be y 5 minus 8. It's equals to y to the power negative 3. So that is the first law of exponents. The second law, we call it quotient powers. In this case, we have a fraction, and then you can see that the bases are the same. So a to the power p divided by a to the power q, it's equals to a to the power p minus q. So you can see that the moment this power goes to the numerator level, the sign changes. It becomes negative instead of positive. The first one, we say that is power of product. This one is quotient of powers. Now let us look at examples. Y to the power 5 divided by y to the power 2. The answer will be y to the power, let me actually use a different color for this one, y to the power 5. The answer will be y to the power, no, actually it's y to the power 2. So the answer will be y to the power 5 minus y to the power 2. And then the answer is equals to y to the power 3. I hope you can see how we apply this law. The third law is power of power. So suppose we have a term which is a raised to the power p inside the bracket raised to the power q. The answer is, it will be a raised to the power p multiplied by q. We simply multiply the powers. So for example, let's say we have z to the power 4 multiplied by 3. The answer will be z multiplied by 4, actually z to the power 4 multiplied by 3, which is equals to z to the power 12. Another example, x raised to the power negative 3 multiplied by negative 5. It will be x negative 3 multiplied by negative 5, which is x raised to the power 15. Another example, x raised to the power 4 multiplied by 2. It will be x raised to the power 4 multiplied by 2, which is equals to x multiplied by 8. This is power of power rule. The next law is the law which is associated with exponent 0. So anything to the 0 power is always 1. So a to the power 0 is equals to 1, and if and only if a is not 0. So 0 raised to the power 0 is not 1. Example, 91 raised to the power 0 is 1. 1000 raised to the power 0 is 1. X raised to the power 0 is 1. X, Y, Z raised to the power 0. Or you can put power 3 here. The answer will be 1. Provided X, Y, Z not equals to 0. So basically anything raised to the power 1, no, anything raised to the power 0 is equals to 1. Our next law, it has to do with the reciprocals. So suppose we have a base raised to the power negative exponent. We check the coefficient of that variable. In this case it's 1, so it will be 1 multiplied by a to the exponent negative p. This is equals to 1, this coefficient, divided by this, but the difference will be the exponent. The sign of the exponent will be positive. Actually, the sign of the exponent will be opposite. So if it's positive, it will be negative. If it's negative, it will be positive. Examples: x raised to the power negative 3 is the same as, since we can see that the coefficient is invincible, so it means we have 1, so it will be 1 multiplied by x to the power negative 3. This is the same as 1 over x to the power 3. So what we are trying to do, we are trying to take this to the denominator level. Another example, 2x raised to the power negative 2. The answer will be 2 over x to the power 2. Our next exponent law, it has to do with 2 terms or 3 terms inside the bracket raised to the common exponent. So a multiplied by b raised to p is equals to a to the power p multiplied by b to the power p. So for example, xy raised to the power 2 is the same as x squared y squared. 2z raised to the power 2 is the same as 2 to the power 2 z to the power 2. Then this is 4z to the power 2. Our next law is similar to the previous one, but you can see that in terms of, instead of multiplication, we have a division sign. So a over b raised to the power p is the same as a to the power p over b to the power p, if and only if b is not 0. So examples, x over 4 raised to the power 3 is the same as x to the power 3 over 4 to the power 3, which is equals to x to the power 3 over 64. X over y squared is the same as x squared over y squared. Our next law is about the radical sign. So we have a term which is base a raised to the power 1 inside the square root, and then we also have an nth term here. This is the same as a, which is the very same base 1, which this one is this exponent over what you see here. So if we have square root of x, we all know that standard form of a radical sign, we have 2 here. There is 2. So actually this is x 1 over 2. This one is here. So suppose we have a different term which is like this, y to the power 3. This is the same as y 3 over 1. No, over 2 actually. Remember there's 2 here. This is the same as a 1 over 4. That's it for this lesson video. This is Wahula SJ. Thank you very much.